Hello students, this is the fourth part of our topic, that is bonding in nitrosyls. We already discussed about pi acid ligands, and carbon monoxide acts as a pi acid ligand. And what are pi acid ligands? Pi acid ligands are ligands capable of accepting appreciable amount of pi electron density from the metal atoms into the empty pi or pi star orbitals of their own are referred to as pi acid ligands. And there are many other pi acid ligands found in organometallic complexes, and some of them are isoelectronic with the carbon monoxide. Okay, and this cyanide Cn minus and NO plus, that is nitrosyl ion, differ significantly from carbon monoxide. For example, that cyanide ion Cn minus is electron rich and is a good sigma base, whereas nitrosyl ion, that is NO plus ions, is electron withdrawing in nature.
Now let us begin with metallic nitrosyls. What are metallic nitrosyls? The coordination compounds of transition metals containing NO plus ion as ligand are commonly known as metallic nitrosyls. Examples are sodium nitroprusside, nitrosoferrous sulfate, etc. In these compounds, the attachment of NO plus ion to the metal takes place through nitrogen atom, and therefore in these ligands NO plus acts as a ligand. Now let's see its molecular orbital configuration. This NO molecule, nitric oxide molecule, contains 15 electrons, that is 7 electrons from nitrogen and 6 electrons from oxygen. Therefore, 8 electrons from oxygen, and total it contains 15 electrons. And let's see the electronic configuration of NO. It is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2 and pi 2py2. Both of them are of equivalent energy, and pi star 2px1 and pi star 2px1 and pi star 2py0. Here we can see that one of the electron enter into the anti-bonding pi molecular orbital. When NO molecule coordinate with metal atom, the single electron in the pi star 2px, that is in the anti-bonding molecular orbital, is transferred to the metal atom, so that NO plus and N minus ions are formed. The NO plus ions are isoelectronic with the carbon monoxide, and therefore it acts as a 2 electron donor. And since oxygen atom is more electronegative than nitrogen atom, it is nitrogen atom of NO plus which coordinate with the metal ion. On the basis of MO theory, we can explain the bonding in these metallic nitrosyl compounds. Now let's see the bonding in nitrosyl compounds. The nitrosyl ligand can bind in two different ways with the metal atom or ion. The first one is linear form, and the second one is the bend form. And in the linear form, the nitrogen atom in the NO molecule is in the sp hybridized state, and it acts as a 3 electron donor. Now let's see the hybridization or the type of bonding in linear form. This express the NO molecule. Here the nitrogen atom is in sp hybridization, so the sp orbitals are aligned in a linear form, and one of the sp hybrid orbital of nitrogen atom combines with the or overlaps with the oxygen atom and forms a sigma bond, and the other sp orbital contains a lone pair of electrons. And one of the p orbital contains a single electron. It is represented in this figure. Okay, and during the metal nitrosyl ligand bond formation, what happens is the metal atom, the sp hybridized orbital overlaps with the vacant orbital of metal atom or ion and thus forms a sigma bond. Metal atom has an empty orbital which combines with the sp hybridized orbital of nitrogen, which contains a lone pair of electrons and thus forms a sigma bond. Whereas the p orbital containing an unpaired electron combines with the unpaired d orbital of pi symmetry of metal ion and thus forms a pi bond here. Okay, this is the type of bonding observed in these nitrosyl compounds or metallic nitrosyl, in which nitrosyl bind in the linear form. Okay, whereas in the case of bent model, what happens is the nitrogen is in the sp2 hybridization and these sp2 hybridized orbitals are aligned in a trigonal planar way. And the picture represents like this, and this blue orbital represents the sp3 hybridized orbital, and one of the sp2 hybridized orbital of nitrogen is overlapped with the oxygen and forms a sigma bond. Okay, and here you can see that a lone pair of electron occupies one of the sp2 hybrid orbital and an unpaired electron occupies another sp2 hybrid orbital. Okay, and now let's see what happens in this case. One electron is being shared with the metal, so there is only one bonding is formed. Okay, ഈ ഒരു സിമെട്രി ഉള്ള ഒരു മോളിക്യൂളുമായിട്ടാണ് അല്ലെങ്കിൽ ഒരു മെറ്റൽ ഓർബിറ്റലുമായിട്ടാണ് അത് ബോണ്ടിങ്ങിന് വിധേയമാകുന്നത്. So the single bond is formed between metal and nitrogen in this way. In this case, the lone pair of electron is present in the non-bonding orbital of nitrogen atom. Okay, and therefore we can say that in the case of electron poor metal, that is, it will have which have vacant d orbitals, metals which have vacant d orbitals is available in the for accommodating the lone pair of electrons, then NO will act as 3 electron donor. They undergo linear binding, and if not, then it will undergo bent type of bonding and will act as 1 electron donor. Bonding in carbonyl compounds nitrosyl compounds ആണ് പറഞ്ഞു നിർത്തിയത്. അപ്പോൾ based on these observations and based on these discussions, you have to write down 2 assignments. Okay, the first assignment is that explain bonding in carbonyls, both bridging and without bridging, nitrosyls and cyanides. Cyanides ഞാൻ ഡിസ്കസ് ചെയ്തിട്ടില്ല, കാരണം നിങ്ങൾ ടെക്സ്റ്റ് റെഫർ ചെയ്ത് അതിൻ്റെ നോട്ട്സ് പ്രിപ്പയർ ചെയ്യേണ്ടതാണ്. നമ്മളിപ്പം കാർബണൈൽ ഗ്രൂപ്പ്സിൻ്റെ ഡിസ്കസ് ചെയ്തു, നൈട്രോസൈൽ ഗ്രൂപ്പ്സിൻ്റെ ഡിസ്കസ് ചെയ്തു. സിമിലർ വേ നിങ്ങൾ സൈനൈഡ്സിൻ്റെയും നിങ്ങളാണ് അത് റെഡിയാക്കേണ്ടത്. ഓക്കെ, പക്ഷേ അസൈൻമെൻറ്റ് വെക്കുമ്പോൾ യു ഹാവ് ടു കംപ്ലീറ്റ് ഓൾ ദീസ് തിങ്സ്. ആൻഡ് ദ സെക്കൻഡ് അസൈൻമെൻറ്റ് ഈസ് ദാറ്റ് ഡിസ്കസ് ദ സിന്തസിസ് ആൻഡ് സ്ട്രക്ചർ ഓഫ് പോളിന്യൂക്ലിയർ കാർബണൈൽസ്. അപ്പോൾ ഇത് ഇമ്പോർട്ടൻ്റ് ആയിട്ടുള്ള ഒരു ഇതാണ്, സ്ട്രക്ചർ ഓഫ് പോളിന്യൂക്ലിയർ കാർബണൈൽസ്. അത് നിങ്ങൾക്ക് ഹൈബ്രിഡൈസേഷൻ്റെ കൺസെപ്റ്റ് വെച്ചിട്ട് നിങ്ങൾക്കത് എക്സ്പ്ലെയിൻ ചെയ്യാൻ പറ്റുന്നതാണ്. ഹൈബ്രിഡൈസേഷനും എല്ലാം നിങ്ങൾ പഠിച്ചിരിക്കുന്നതുകൊണ്ട് അതുകൊണ്ടാണ് ഞാനത് വലിയ ഡീറ്റെയിൽഡ് ആയിട്ട് ഇവിടെ ഡിസ്കസ് ചെയ്യാതിരിക്കുന്നത്. ആൻഡ് യു ഹാവ് ടു പ്രിപ്പയർ ദിസ് അസൈൻമെൻറ്റ് ഓൾസോ, ആൻ അസൈൻമെൻറ്റ് ഓൺ ദിസ് ടോപ്പിക്സ് ഓൾസോ. എല്ലാവരും ഈ അസൈൻമെൻറ്റ്സ് ചെയ്യേണ്ടതാണ്. ആൻഡ് should be present it in the should submit it in the Google Classroom. Okay. Thank you for listening. Have a great day.